Okay, so what we're going to be doing today is we're going to be applying some trig functions. So a cool acronym that I learned from the principal of the high school taught me this one. A cool acronym for remembering the order of the trig functions for all the trig functions is some old hippie caught another hippie tripping on acid. So the way this works is you have your sine function, sine, and that's opposite over the hypotenuse. Right? And then for cosine, we have adjacent over hypotenuse, caught another hippie. And then tripping on acid for tangent. Right? So there's an acronym you can use to remember it. Some old hippie caught another hippie tripping on acid. So now when applying trig functions, right, we're going to start off with a basic example. So you got a triangle, right? This angle is a right angle. We'll say this angle is 35 degrees. We'll say this is angle P. This is angle Q. This is angle R. So that would make this line Q, line P, and your line R equals 14. We'll say inches. Right? And so when solving, say we want to solve the triangle for Q. We want to solve this side length. So what we're going to do is that we know that we have this angle, right? And we know that we have this measurement. This measurement is also hypotenuse. So this whole way you'd set this up is since you're looking, this would be the opposite to this angle. So P would be opposite of P. So that means that Q is adjacent to P. So that means you're going to use cosine because cosine is opposite over adjacent over hypotenuse. So you have cosine is cosine of P is equal to Q, which is your adjacent over your hypotenuse, which is 14. So now we know what equation we're using. So we know that angle P is equal to 35 degrees. So cosine P, which is 35, equals Q over 14. Now you want to get Q by itself, so what you're going to do is multiply 14 by both sides. Right? So this gives you the equation of 14 cosine of 35 degrees equals side length Q. And now what you're going to do is you're going to pull up your calculator, right? Turn that bad boy on. So clear all that. Mode. No, that's not mode. That's mode. We're going to go into degree mode because we are not in calculus. Right? So you type in this equation into the calculator. So that means you have 14 cosine 35 parentheses equals Q. So you enter that, and that gives you approximately 14.11.5. So that means cosine of Q, Q is equal to 11.5. And then knowing that, you can use the Pythagorean theorem to find an angle for the side length P. And we already have two angles, so you can find this angle. So another example, this time we'll apply it, so like if in the real world, So say you have a building structure, right? There's a nice little building, right? And you know the building is 40 feet tall. And then you have a piece of rope coming from the building. Sorry, no. Here's your piece of rope. It's anchoring the building down, we'll say. R for rope. So you know that the building is 40 feet tall, and then you know that this degree is 52. And that's right angle. And then this is distance. What we want to do is we want to solve for R, and then we want to solve for the distance. You want to find out the length of the rope, and then how far the base of the rope is from the base of the building. So when solving for R, we're going to use sine because you have this angle, and sine is opposite over hypotenuse, and R is the hypotenuse. And since 40 is opposite of 52, your equation is going to look like sine 52 degrees is equal to 40 over R, because R is the hypotenuse, so that's on the bottom. So when configuring these equations, right, you multiply R by both sides. So R of sine 52 degrees equals 40, and then divide by sine 52 degrees, and then it leaves you with R equals 40 over sine of 52. So then you go back to your calculator, and you plug that equation in. So you have 40 divided, make sure you add parentheses, cosine, it's 52 degrees, and then you enter, and you're left with about, so actually we'll do 40 divided by cosine 52. At 64.9, R equals 64.9, which is about 65 feet. So R is about 65 feet. Right. So now you also got to solve for D, right? And you could use the Pythagorean theorem, but we already know that. So, but we're going to use tangent just to apply all the functions. So when solving for D, we know that we know that this is 40, right? And we have this angle. So because these are next to each other and you're not using the hypotenuse, it's going to be tangent. So tan 52 degrees equals 40 over D. So it's adjacent over opposite. No, opposite over adjacent, tripping on acid, right? So then you do that same thing over here, where it gives you D equals 40 over tan of 52. And you go back and plug that into your calculator. Okay, so then you plug that in, so you have 40 divided by tangent right of 52 degrees. Enter, and that's 31 about. So D equals about 31, and this is not 64 because I plugged in cosine and the sine function. So we'll do that real quick again. So it was 40 divided by sine of 52, and it's 50.7, which is about 51. Yeah. So in a real world problem, if you had to figure out the length of the rope, you could do that, and you had to figure out how far the base of the rope is from the building, you could do that now. So a bit more of a trickier problem we have is with a variable. So say you got a nice little volcano over here. Bam, there's a volcano. Right, there's a volcano. have this length, right? Coming from the volcano, right? We'll say that's 90 degrees. And then you have this right here. Now we'll say that that angle is 40 degrees. We'll say this angle is 37 degrees. We'll say from here to here is 1,000 feet. And we'll say this is x and this is h for height, right? So now what we're going to do is we're going to solve for x and solve for h. So solving for h is probably the easiest thing to do first, because you can. So yeah, actually we're going to solve for x to get our base and then solve for h. So we know that tangent of 37, right, is h over 1,000 plus x, because it's opposite over adjacent. So that equals h over 1,000 plus our x, and that gives you the base. We also know that tangent of 40 is equal to h over x, same opposite over adjacent. So now that we know that tangent of 40 is equal to h over x, and tangent to 37 is equal to h over 100 over x when solving for, so now you're going to get both these equations to equal x, right? So this one would be 1,000 plus x times 37 tangent for tangent of 37 equals h. And this equation equals x times tan of 40 equals h. So now that you know they both equal h, that means you know that these two are equal to each other. So you can set up that equation as 1,000 set that up as 1,000 plus x, right, times tangent of 37 degrees. Now we know that these two are equal, so that is equal to x tangent of 40 degrees. So now it's just an algebraic problem and you're solving for x. So now what I would do is you distribute these factors, right? So you get 1,000 tan 37 plus x tangent of 37, if you distributed that, equals the x tangent of 40 degrees, right? So then what you can do with that is you could multiply x tangent from this side to this side, because it's essentially the same thing, just different degree. So minus x tangent 37 minus x tan 37. Multiply, subtract it from both sides, and this will give you, right? So that leaves you with 1,000 tangent of 37 degrees is equal to x tan 40 minus x tan 37. And we want to solve for x, right? So what we're going to do is we're going to pull x out of this by dividing this by x. Actually, no, we're just going to pull x out as the greatest common factor, right? So you have 1,000 tan 37 degrees is equal to x times tan of 40 minus tan 37. Right? So now what we do is we can say now we can say this equation is equal to x equaling 1,000 tan of 37 over tan 40, right? tangent 40 degrees minus tangent 37 degrees. And you get that by dividing this by both sides. So divide that by this side, that leaves you with that equation. And now you plug that into your calculator, right? So you plug that in. So it's 1,000. It's 1,000 of tan 37 divided by tan 40 minus tan 37. Tangent 40 minus tangent of 37. Right? That should give you about 8,808, right? So we come back here. So now we know that x is about equal to 0.8, right? So what we wanted to do, come back here, we want to solve for x. Now we know, we want to solve for h. Now we know what x is equal to. We can plug in tangent of 40, because you're not using the hypotenuse. So it's opposite over adjacent. And we don't know, we're solving for h now. But now we know what x is. 0.8, right? So now you just convert that back to that same thing we did earlier. Multiply by 8,000, 8.8, bam. Multiply 0.8 to give you the the new format of 8 tangent of 40 is equal to h. Now that it's in that form, you just go back to your calculator and plug it in. It's 8808.8, and that's tangent of 40, right? And that should give you about 7,391, right? So it was 7,000. So now h equals 7,391. So and that gives you the, so when solving for the height of this volcano, you had this angle and you knew that it was 1,000 feet from this angle, you could solve for the distance you are from here to the base of the volcano, and now you can solve for the height of the volcano. Ta-da!